Here we want to solve this system using substitution. In other words, we want to find the ordered pair that solves both of these at the same time, the simultaneous solution. What I first notice is that the first equation, I can get y by itself. I could solve for y simply by subtracting 3x. Doing that, you'll be left with y equals negative 3x plus 4. That's step number 1 in substitution. Then what we're going to do is take that y value and substitute it into the other equation. All right, this is the substitution step. You got 8x plus 2 times y, put a blank parentheses, equals 10. Now we just figured y from the previous equation is negative 3x plus 4. Okay, so I solved for y on the first equation and substituted into the second equation. Now the only variable that's left is x, and we can use regular algebra to solve for that. So 8x minus 6x plus 8, distributing the 2, equals 10. Then I have same side like terms. 8 minus 6 is 2x. 2x plus 8 equals 10. Then subtracting 8, 2x equals 2, so x equals 1. Now, when you have answers here, answers are always going to be, if there is an answer, they're always going to look like x comma y. Now, for the answer, we just found x. We're only halfway done. To find the corresponding y value, what you then have to do is what's called back substitute. Okay, when we back substitute, you can plug x back into any one of these three equations. But since we already solved for y, we might as well plug it into this one. Alright, so to figure out the corresponding y value, let's take negative 3, multiply it times the x, and then add 4. So here I'm going to back substitute x into that. Okay, so that leaves me with negative 3 plus 4, or 1. So the corresponding y value when x is 1 is 1. So 1 comma 1 should be the simultaneous solution. That's my answer to the system. Now let's check. When I plug in 1, I got 3 times 1 is 3, plus 1 is 4. It looks good. 8 times 1 is 8, plus 2 times 1 is 2. 8 plus 2 is 10. So notice 1, 1 solves both of those at the same time.